I've been practicing test-driven development on Android since 2014, and in this video I'm gonna break down all the different kinds of test doubles that you can use when it comes to testing your code. And I'll do that by utilizing a practical code example. Let's dive in.
In a nutshell, test doubles are substitutes that we use to replace the real components that our system under test interacts with. They help us isolate the code being tested by replacing real components with simplified controllable versions. Now, before we move on, I want to point out very important terminology thing related to test doubles. Traditionally and historically, many people refer to all test doubles as to mocks. However, as we can see very shortly, a mock is a very specific kind of test double. So when people are talking about mocks, make sure that you understand, are they talking about a specific mock test double or about test doubles in general? Now let's move on and do some coding to understand different kinds of test doubles in practice. Now we want to write some automated tests for this authorization system. The first thing I want from this authorization system is to tell me how many users are currently authorized. I'm gonna go ahead and write a test for it. If you're not familiar with writing basic tests, a test is a function that is annotated with test annotation and it returns unit or void in Java terms. And so I'm gonna name my test according to the behavior that I'm expecting it to cover. Now let's focus on the body of this test. The first super important lesson of this course is to always start from the assertion. Type the assertion in a way that it will be super easy, super clear for you to understand what's being checked when you read it afterwards. Do not fear that the line doesn't compile. As we mentioned in the theoretical part of this course, non-compiling test is also a failing test. So when it doesn't compile, that's fine. Just write what you want to read and do one step at a time. We are going to resolve the compilation issues later. So here, I'm going to make sure that the authorized users count is equal to 0. Now that I have this line written, I would reflect and see whether it makes sense to me, and it's going to be easy for me to understand months later when I open this file, is it clear what is this testing or not? This looks pretty good to me, and only now I'm going to go ahead to the next step, which is making this compile. First, I'm going to import this function assert that, and next I'm going to focus on the authorized users count. To make this compile, this authorized users count should come from somewhere. I can leverage Android Studio to help me create a local variable for that, and instead of assigning a value here, I'm going to make a call to my authorization system because that's where this value should come from. Now, pay attention what's happening here. I'm making a call to a non-existing thing, which means I am designing the API already. This is where I am shaping the public API of my classes and my system in general. And in that sense, my tests are the first users of my solution. They give me instant feedback. What am I doing, whether the APIs that I'm creating are making sense, and whether they are easy to use. Isn't that amazing? Absolutely. Now again, I end up with a failing test because the system is not compiling. Now let's go ahead and instantiate the system. And again, I'm going to ask Android Studio to help me create this thingy. I'm going to instantiate it by making new instance of the authorization system. And as you're noticing, I'm slowly getting towards a green test, but I'm doing one step at a time. At this point, I have two compiling issues. Let's address them one by one. First off, this authorized users count is not a function that is existing in the authorization system class. First, we have to fix that. Again, we are going to ask Android Studio to create member function inside for us. Even though it is tempting to jump in and write implementation here inside, we have to postpone that. We have to do one step at a time. And our first goal is to get this test green. And currently it is still red because it's still not compiling. So let's first go ahead and fix that. Now here is where the things are getting interesting. In order to construct the authorization system, we have to pass an instance of the email validator. However, this behavior that we are trying to cover in this test is not and should not be influenced by the email validator at all. That's where the dummy test double comes into the game. Dummy is a test double that we use to fill out parameters list. With other words, we use dummy to pass it as an argument where needed, but we know that it won't be used at all. Let's create a dummy email validator and pass it in the authorization system constructor here. We will let this newly created class implement the function from the inherited interface. There we go. We've just created a dummy test double. Beware though, it is not the name that makes this test double a dummy. Instead, it is the implementation. So for the implementation here, we have this to do, which in fact will throw an exception if call to validate is being made. And that's exactly what we want. We use dummy to supply a parameter list, and we want to make sure that nobody is making calls to it. In fact, possible calls made by mistake are going to lead to an exception being thrown. And that's exactly what makes this test double a dummy. At this point, we can go ahead and run the tests and see what happens. We are expecting this test to fail because we don't have an implementation for the authorized users count function. And to fix it, we can simply write an implementation and return 0 in the authorized users count function. That should make our tests green. Next up, let's imagine a functionality where we want to authorize a user. Naturally, we wouldn't like to proceed to the authorization without having an email with a valid format. Now let's also imagine that the email validation functionality is already taken care of. we want to directly proceed to the code that's going to do the authorization. We may come up with a new test that's going to be checking successful authorization. As an assertion, I would like to check if the authorization result is equal to true. The authorization result then will come from the authorization system by calling an authorize function that will take in an email and a password. Now once again, pay attention what's happening here. Inside the test, we are writing the API or we are shaping it. How do we want it to be? So from the test, we are designing our system. And since we don't know what email and password are just yet, as a tip, it would be better if we start off with them to define them as types, and then Studio will use the type inference to imply when extracting functions and classes afterwards. So first I'll create a local variable for the email, followed by doing the same for the password. Next I'll create an instance of the system, and I'll let Studio to create this authorize function for me. I'll make this function return Boolean for now. Now, as mentioned before, we wouldn't want to proceed with the logic if the email is not valid. So first we are going to check for a valid email. Now, note that I'm diverging a little bit from the regular steps in TDD, so I wrote a little bit of code, and that's deliberate for the sake of this example and argument, so bear with me for now. To complete the test, we need to pass an instance of the email validator. Considering that the email validation functionality is already taken care of, we want to focus on the code that is inside this if block. And in order to be able to get inside the if all the time, we need this condition to hold true always. And that's where the stub test double comes into the game. Stubs, by their nature, provide constant results for the calls done to them. And so, since we want to enter inside the if statement, we need to provide a valid email always. And since we know that the email validation is already completed, we don't want to retest that here again. And furthermore, it would introduce unnecessary coupling, which means if we have to change something regarding the email validation, we'll have to change these tests here as well. Or with other words, if there is a bug in the email validation system, these tests are going to fail as well, and they shouldn't, because they are not about email validation. Let's create a stub email validator and pass it into the authorization systems constructor. And since we don't have this stub yet, let's go ahead and create it. We're going to create a new class for it, and we're going to keep it here inside the tests. I'm going to let this newly created class to implement the inherited functions from the interface. And as an implementation, I'm going to let it return true always. And there we go. I've just created a stub test double. By using this test double, we'll be able to focus on the code that is interesting only for a particular test. In this case, our successful authorization test case. If I go ahead and run the tests now, I'll get back a failure saying that there is missing implementation. Let's go ahead and write the implementation that is missing. I'll go ahead and write a simple implementation that's going to be sufficient to make the test pass. Now let's run the tests and see what happens. We are back to green. Even though this implementation is not very useful, we understood what a stub test double is and how and when we can use it. Now let me collapse these tests that are passing and let's move on. What if we want to make sure that the email validation has been called from our system? To do so, we are going to leverage the spy test double. A spy test double records information about the calls made to it, such as number of times something was called and the arguments passed. To introduce one, we are going to write a new implementation of the interface, and I'm going to let it override the inherited function. Since this particular spy should always accept the validation, we are going to return true here, just as we did with the accepting email validator. However, we are going to keep track of this validate function being called. The simplest way to do so is by introducing a Boolean property that we can manipulate when this function is being called. I'm going to set this property to false by default, and when the function is called, I'm going to set it to true. Back to our test, we can use this test double to make sure that the validation was called when making an authorization. First, I'm going to replace accepting email validator with the spy, and then I'm going to extract it into local variable. Then I can write additional assertion to make sure the email validation was called. Let's run the tests. We confirm our tests are passing. A little bit more sophisticated kind of spy test double is a mock test double. Mock test doubles are objects pre-programmed with expectations about the calls they are about to receive. They may throw an error if they haven't received the expected calls. What differentiates mocks from spies is that the mocks know what they are testing. The actual verification is happening inside the mock itself. They are not interested about the return values of the functions. Instead, they care about the functions that are being called, the arguments that are being passed, when and how often. In that sense, mocks are testing behavior. You must be very careful when using spies and mocks, because they tend to couple themselves with the implementation details of the system you are building, and so you may end up with fragile tests. A fragile test is a test that breaks for reasons that are not supposed to break a test, such as changing production code. Now, of course, changing a production code may break a test. Well-designed tests are minimizing that, while mocks and spies are working against it. To create a mock test double, once again, we are going to create a new class that will inherit from the email validator, followed by overriding the inherited function. Just like we did with the accepting email validation SPY, we are gonna always return true here. However, we are gonna keep track of how many times the validate function has been called. We may also keep track of the actual value of the email that's being passed when calling the validate function. But for the sake of understanding this test double, keeping it simple will be enough. So we are gonna increase this counter on each call of the function. Finally, to make this test double a real mock, it should know what it tests. We can expose a function to verify the count of times the validate function has been called. We may even go a step further and make this function throw an exception if the expected count was different than the actual count. So I'll remove the return type. I'm gonna wrap this into an if. And here I would say if the times called is different than the validation call count, we are gonna throw an assertion error. It will certainly make the test fail, but instead of returning a result, it's gonna throw an assertion error if there is a difference between the expected and the actual call count. Now, to release some dopamine, let's plug this test double into the code and see it in action. I'm gonna go ahead and replace the accepting email validation SPY with this new mock. Then, in the place of the assertion, I'm gonna call the verification. If I run the tests, they should remain passing. And to make it fail, let's add one more validation call in the production code. Now let's run the tests and watch that fail. As we can see, we are having a very clear failure, saying incorrect count of calls to validate, expected 1 but was 2. So let's remove this call and run again to go back to green. So far, we've looked into 4 different kinds of test doubles. We could say that a mock is a kind of SPY, SPY is kind of Stub, and a Stub is kind of dummy. The last kind of test double that we are going to cover here is not a subkind of any of these. It is fundamentally different type of test double, and it's called fake. Fake test doubles are working implementation of the actual system, but they most of the time take shortcuts and they are not suitable for production. In that sense, they do expose a real business behavior and they can act differently by feeding them with different data. So we can say that a fake test double acts as a simulator. One example would be an in-memory database. And it's not surprising if a fake test double is covered with tests too. Let's create a fake email validator by extending the email validator interface and overriding the inherited function. As an implementation of the validate function, we can check whether the incoming email is part of a preset collection of emails that we can pass when creating an instance of the preset email validator class. And so the valid emails will be taken as constructor parameter. As a type here, I'm gonna pass list of strings, and let's refactor. Let's improve the formatting here. And that's it. We've just created a fake email validator. The business behavior of this particular test double is to check whether the email is part of a preset collection of emails that's being passed when creating the preset email validator. Now to complete the exercise, let's see this test double in action. Here, instead of the accepting email validation mock, I'm gonna use my new preset email validator. I'm gonna pass down the email that we are using in the test as an argument in a constructor. Finally, I'm gonna remove the non-compiling verification line, as this test is implicitly checking whether the email validation happened or not. If I run the tests, they should pass. If I pass a different email here, or an empty list of emails, the test will fail. That's pretty much everything you need to know about the test doubles. We saw their ins and outs, and we saw how we can use them in different situations. Next up, we can start working on the application that we are about to build in this course. And before we do so, as a quick summary, in this section we saw what are the test doubles, what are the different kinds of test doubles and how we can use them, and we saw practical code examples of how each and every different kind of test double looks like. See you in the next section.